So, hi guys. So this is ACI 1 analog aircraft instruments. So this is module 2 and we will talk about the types of pressure and the pressure measuring instruments or pressuring instruments. So as said in the module 1, the pressure measuring instruments can be found in the light group and the engine group. So they can be either direct reading or remote sensing, and pressure measurement involves some sort of mechanism that can change sense in pressure. So again, there are three fundamental pressure sensing mechanisms: the Bourdon tube, the diaphragm or bellows, and the solid state devices. So now here, we will talk about the type of pressure. So the pressure is comparison between two forces. So we have the absolute pressure exists when a force is compared to a total vacuum or absolutely no pressure. So it is necessary to define the absolute pressure because the air in the atmosphere is always exerting pressure on everything. Kahit sabihin natin walang pressure na in-apply, katulad sa deflated balloon, there's still atmospheric pressure inside and outside ng balloon. So to measure the atmospheric pressure, it is necessary to compare it sa absolute or sorry, compare it to the total absence of pressure such as a vacuum. So sa lahat ng aircraft instruments, ginagamit yung absolute pressure values such as altimeter, the rate of climb indicator, the manifold pressure gauge, katulad nung sa may aneroid. So the most common type of pressure measurement is gauge pressure. So this is the difference between the pressure to be measured and the atmospheric pressure. So the gauge pressure inside the deflated balloon na sinabi natin kanina is therefore 0 pound per square inch. Or PSI. So gauge pressure is easily measured and is obtained by ignoring the fact that the atmosphere is always exerting pressure on everything. So example natin, yung gulong na may air to 32 psi at sea level, location and check with a gauge to read 32 psi. So approximately 14.7 psi of air pressing on the outside of the tire is ignored. Ulit natin. 32. And then, meron kang 14.7 outside. Sa loob, meron kang 32. So approximately 14.7 of air pressing on the outside of the tire is ignored. So the absolute pressure in the tire is 32 psi plus the 14.7 psi that is needed to balance the 14.7 psi on the outside of the tire. So the tire's absolute pressure is approximately 46.7 psi. So if the same tire is inflated to 32 psi at the location of 10,000 feet above sea level, the air pressure on the outside of the tire would only be approximately 10 PSI. So, ulitin natin. Pag nandito ka sa land, okay, and yung gulong mo is may tire pressure na 32 PSI, and the standard atmospheric pressure at sea level is 14.7 PSI. So, yung absolute pressure mo is 46.7 PSI. Pero, pag yung same tire is inflated ng 32 PSI and located siya 10,000 feet above sea level, the air pressure on the outside of the tire would only be approximately 10 PSI due to the thinner atmosphere. Okay, so ibig sabihin, pag tumataas ka above sea level, or tumataas ka ng thousands of feet, bumababa yung uh, atmospheric pressure. So the pressure inside the tire required to balance this would be 32 psi plus 10 psi. So the absolute pressure of the tire is 42 psi. So the same tire with the same amount of inflation and performance characteristic has different absolute pressure values. So gauge pressure, however, remains the same, indicating the tires are inflated identically. So in this case, gauge pressure is more useful in informing the condition of the tire. Okay? So yun. Yun yung silbing ni gauge pressure. So sa gauge pressure measurements are simple and wide useful. So tinatanggal nila yung measure varying atmospheric pressure to indicate or monitor the particular pressure situation. So gauge pressure should be assumed unless otherwise indicated or unless the pressure measurement is of a type known to a required absolute pressure. So, sa lahat ng klase ng aviation, it is desirable to compare the pressure of two different elements to arrive at useful information for operating the aircraft. So, when two pressures are compared in a gauge, the measurement is known as differential pressure. And the gauge is differential pressure gauge. So, an aircraft's airspeed indicator is a differential pressure gauge. So, kino-compare niya yung ambient air pressure with ramp air pressure. Okay? So, pag sinabing ambient air pressure, yung outside, and then yung ramp air pressure, yun naman yung kung ano yung tumatamang hangin dun mismo sa aircraft. To determine how fast the aircraft is moving through the air. The turbine engine pressure ratio or EPR gauge is also a differential pressure gauge. So it compares the pressure at the inlet of the engine with at the outlet to indicate the thrust developed by the engine. So both of this differential pressure gauge and other are lahat makikita nyo mismo sa mga gauges. And ito, katulad din ng nababasa nyo dito, many aircraft instruments make use of absolute pressure values such as altimeter, the rate of flight indicator, and the manifold pressure gauge. Additionally, sa aviation, there are also commonly used pressure known as the standard pressure. So, ito yung madalas yung makita sa aircraft, yung standard pressure. So, standard pressure refers to an established or standard value that has been created for atmospheric pressure. So the standard pressure value 29.92 inches of mercury. Pwede din siyang 1,000 or 1013.2 hectopascal or 14.7 psi. So it is a part of a standard day that has been established that includes a standard temperature of 15 degrees at sea level. So specific standard day value have also been established for air density, volume, and viscosity. So lahat ng values ay dine-develop average since the atmosphere is continuously fluctuating. So ginagamit sila ng mga engineers pag nagde-design ng instrument systems and ginagamit din sila ng technicians and pilots. So using a standard value sa mga atmospheric pressure is more desirable than using the actual value. So for example, okay, 18,000 feet and above, okay, lahat ng aircraft gumagamit ng 29.92 inches of mercury as a reference pressure for their instruments to indicate the altitude. So this is results in altitude indication in all cockpit being identical. So lahat ay accurate means is established for maintaining vertical separation of aircraft flying at this high altitude. So ulitin natin si aircraft, meron silang setting na 29.92 inches of mercury at 8,000 feet. Okay? Dahil, example, lumilipad si aircraft sa Pilipinas and merong aircraft sa China. Magkaiba lagi ng pressure. Pero, when nag-set sila ng standard pressure sa may aircraft ng 29.9, kahit gaano sila kalayo, magkakasalubong sila, okay, madidetermine nila yung height nila and their vertical separation. Okay? So, ulitin natin, nag-iiba-iba kasi yung height pag nasa iba-iba kang lugar. So, paano mo madidetermine yun? By setting a standard pressure na kinait ng mga engineers. So now, in pressure instruments, meron tayong engine oil pressure. Okay? Sa engine oil pressure, the most important instrument na ginagamit sa pilot to perceive the health of an engine. Itong engine oil pressure gauge. So, oil pressure is usually indicated in PSI. Kaya kung nakikita nyo dyan, oil pressure in PSI. The normal operating range is typically represented by the green arc. So, kung nakikita nyo dito, merong green arc on a circular gauge. So, for example, for exact acceptable operating range, syempre magko-consult sila sa manufacturer's operating and maintenance data. Sa reciprocating and turbine engine, oil is used to lubricate and cool bearing surface na kung saan lahat ng parts ay may nagro-rotate, nag-slide each other at high speed. So a loss of pressurized oil to these areas would rapidly cause excessive friction and over temperature conditions, leading to catastrophic engine failure. So, katulad ng sinabi ko, Okay. Yung aircraft using analog instruments, gumagamit ng direct reading Borden tube, oil pressure gauge, and ganyan pinapakita sa may figure niya. Sa mga digital instrument system, use an analog or digital remote sensing pressure. So again, for exact acceptable operating range, consult nyo yung manufacturer's operating and maintenance data. Sa reciprocating engine and turbine engine, uh, yung oil is ginagamit for lubricating and to cool the bearing surfaces na kung saan may mga parts na nagro-rotate or nag-slide at high speed. A loss of pressurized oil to these areas would rapidly cause excessive friction and over-temperature conditions and may lead to catastrophic engine failure. And as I have mentioned, aircraft using analog instruments gumagamit ng direct sensing, Borden tube oil pressure gauge, and dito sa may figure na to, nakikita nyo, shows the instrument face of the typical oil pressure gauge of this type. In digital instruments, use an analog or remote oil pressure sensing unit that sends output to the computer driving display of oil pressure value on the aircraft's cockpit display screen. So oil pressure may be displayed in a circular or linear gauge fashion and may even include a numerical value on the screen. So yung mga oil pressure is grouped with other engine parameters displayed on the same page or the portion of a page on a display. Katulad lang nitong nakikita nyo. Yan. So kung nakikita nyo dito, ito yung mga other parameters na pwedeng makita. Merong ang oil temperature, oil pressure dito, pwede nyo ito, fuel flow, yan. So ganyan pinapakita yung sa pag-digital. Next, manifold pressure. So in reciprocating engine aircraft, the manifold pressure gauge indicates the pressure of the air in the engine induction manifold. So this is an indication of power being developed by the engine. So the higher the pressure of the fuel air mixture going into the engine, the more power it can produce. Sa mga normal na aspired engines, this means that an indication near atmospheric pressure is maximum. Sa mga turbocharged or supercharged engine, pressurize the air being mixed with the fuel, so full power indications are above atmospheric pressure. Sa mga manifold pressure gauge are calibrated in inches of mercury, although digital display may have an option to display a different scale. So a typical analog gauge makes use of an aneroid described nung sinabi natin kanina about sa aneroid. So the connected pointer indicates the current air pressure. So a line running from the intake manifold into the gauge presents intake manifold air pressure to the aneroid, so the gauge indicates the absolute pressure in the intake manifold. Lipat lang muna natin. Ulitin natin ha. So, kung nakikita nyo dyan sa may leftmost part, an analog APR gauge from a turbine engine. So, sa a typical analog gauge, gumagamit sila ng aneroid. So, si atmospheric pressure acts on the aneroid inside the gauge. So, the connected pointer indicates the current air pressure. So, a line running from the intake manifold into the gauge presents intake manifold air pressure to the aneroid. Kaya mag-indicate siya ng absolute pressure in the intake manifold. An analog manifold pressure gauge along with its internal workings is makikita yan sa image niya. So the digital presentation of manifold pressure is at the top of the engine instruments displayed na may multi-function display, which is ito. Yan, manifold intake, dyan. So the aircraft's operating manual contains data on managing manifold pressure in relation to fuel flow and propeller pitch and for achieving various performance during phases of run-up and flight. Now we will talk about the engine pressure ratio. So sa mga turbine engines have their own pressure indications that relates the power being developed by the engine. It is called the engine pressure ratio indicator or EPR gauge. So itong gauge na to compares the total exhaust pressure to the ram air of the inlet of the engine. So with adjustment for temperature, altitude, and other factors, yung EPR gauge present an indication of the thrust being developed by the engine. So since the EPR gauge compared to pressure, isa siyang differential pressure gauge. So it is a remote sensing instrument that receives its input from engine pressure ratio transmitter or in a digital instrument system display from the computer. So yung mga pressure ratio transmitters contains the bellows arrangement that compares the two pressure and converts the ratio into an electric signal na ginagamit for indication. So, balikan lang natin, no? Yung image na to. So the pressure ratio transmitter contains the bellows arrangement that compares the two pressure and converts the ratio into electric signal used by the gauge for indication. Katulad itong balikan nga yung figure 10-16. So an analog manifold pressure indicator instrument calibrated in inches of mercury, the left. So the internal workings of an analog manifold pressure gauge are shown on the right. So the air from the intake manifold surrounds the aneroid, causing it to deflect and indicate pressure on the dial through the use of linkages to the pointer. Next is the fuel pressure. So sa fuel pressure, nakita nyo sa image na yan, a typical analog fuel gauge. So fuel pressure gauge provide information to the pilot. Typically, hindi siya kung gaano kadami yung gasolina sa eroplano. But, yung fuel is pumped out of various fuel tanks on the aircraft for use by the engines. So, yung pag-pump niya, yung tinitignan dito. So, a malfunction fuel pump or tank that has been emptied beyond the point at which there is sufficient fuel entering the pump to maintain the desired output pressure is a condition that requires the pilot's immediate attention. So, hindi lang natin Okay, pag nagmamalfunction si fuel pump, syempre, at yun yung kailangan ng immediate action na tutukan ng piloto. Kasi syempre, ginagamit naman din to fuel pump na to. Example, if sa left engine, okay, then, pag nagmamalfunction si fuel pump, dapat tinututukan because it's important na hindi lang palagi nasa right yung fuel, so they need to pump it on the left side. Siyempre, yun din, for the purpose of mag-balance yung aircraft. So, while direct sensing fuel pressure gauge using Bourdon tubes, diaphragm, and bellow sensing arrangements exist, um, hindi particular and it's undesirable na to run a fuel line into the cockpit due to potential for fire, leak, or yung gas leak, and then, yun nga, pwede siyang mag-create ng fire. So therefore, the preferred arrangement is to have whichever sensing mechanism that used to be part of a transmitter device that use electricity to send a signal to indicator in the cockpit. So indications monitoring the fuel flow rate are used instead of fuel pressure gauge. So fuel flow indications, especially in modern aircraft, uses remote sensing. So ulitin lang natin, syempre, sa fuel pressure example sa may Cessna, okay, sa may Cessna, itong part na to is harang to mismo dun sa may piloto. So, syempre, kung meron silang may part ng indication din na hindi pwedeng maglagay ng fuel line around the pilot. Ayun, dahil syempre, may potential na mas higher siya sa fire risk. Okay, kaya yung fuel line from the cockpit is iniiwas. Yun lang naman. So, sa hydraulic pressure naman, hydraulic systems are commonly used to raise and lower the landing gear, operate light controls, apply brakes, and more. So, sufficient pressure in the hydraulic system developed by hydraulic pumps or pump is required for normal operation of hydraulic devices. So, hydraulic pressure gauge are often located in the cockpit and at or the near hydraulic system servicing point on the airframe. So, remotely located indicators used to maintenance personnel are almost always direct reading Borden tube type gauges. So, the cockpit gauge usually have system pressure transmitted from sensor or computers electrically for indication ng hydraulic pressure. Yan, kung titignan nyo dyan sa image, hydraulic pressure transmitter in place in a high pressure aircraft hydraulic system. So, itong transmitter sends and converts pressure into an electric output for indication by the cockpit gauge or for use by a computer that analyze and display the pressure in the cockpit when requested or required. So, meron naman tayong vacuum pressure. So, gyro pressure gauge or vacuum gauge or suction gauge are all terms for the same gauge used to monitor the vacuum developed in the system that actuates the air-driven gyroscopic flight instrument. Okay, so madalas ito din inaano sa gyroscopic instrument. So, kung titignan nyo naman, ano ba yung gyroscopic flight instrument? Katulad yan ng attitude indicators, heading indicators, and turn coordinators. So, ulitin lang natin, mga gyroscopic flight instruments of descriptions are used in general aviation aircraft and sa mga older commercial aircraft. Ulitin ko lang ulit there are three main gyroscopic instruments. Kasama na din si artificial horizon, the heading indicators, and the turn coordinator. So, itong vacuum pressure, air is pulled through the instrument causing the gyroscope to spin. So, the speed at which the gyro spin needs to be within a certain range for correct operation. So, the speed is directly related to the suction pressure that is developed in the system. So, the suction gauge is extremely important sa mga aircraft relying sa mga vacuum-operated gyroscopic flight instruments. So, pag may mga, ulitin natin, pag may mga vacuum-operated gyroscopic flight instruments, nandito itong si vacuum pressure. So, itong si vacuum pressure is a differential pressure indication, meaning the pressure to be measured is compared to the atmospheric pressure through the use of a sealed diaphragm or capsule. So, yung gauge na to is calibrated into inches of mercury. So it shows how much less pressure exists in the system than in the atmosphere. Now, meron tayong pressure switches. So, itong pressure switches na to in aviation, ginagamit to sufficient to simply monitor whether the pressure developed by a certain operating system is too high or too low, so that an action can take place should one of these conditions occur. So, itong pressure switch is a simple device usually made to open or close an electric circuit when a certain pressure is reached in the system. Okay? In short, switch siya. Nag-on siya, on-off. So, it can be manufactured that electric circuit is normally open and then closed when a certain pressure is then, or the circuit can be closed and then open when the activation pressure is reached. So pressure switches contains diaphragm. Yan, titingnan natin dito. Okay, pressure switches, yung diaphragm yun. So pressure switches contains diaphragm to which the pressure being sensed is applied on one side. So the opposite side of the diaphragm is connected to a mechanical switching mechanism for an electric circuit. Okay. Yan. So example, ito atmospheric pressure. So a normally open pressure switch positioned in an electrical circuit causes the circuit to be open as well. So the switch closes, allowing electricity to flow, and the pressure is applied beyond the switch activation preset point. Normally closed switch are allow electricity to flow through the switch in a circuit, but open when reaches a preset activation point, thus opening the electrical circuit. So ulitin lang natin. So ito yung atmospheric pressure, which is nandito. So, pag hindi tumataas yung pressure na kailangan niya dito sa inlet, hindi niya matutulak itong mechanical linkages na nandito para mapindot niya si switch. Okay, so ulitin lang natin ha. Itong pressure switch contains a diaphragm. Which is nandito. Sorry, yan. Ito, yung diaphragm yan. So the opposite side of the diaphragm is connected to a mechanical switching mechanism for electrical circuit. Is yan. So small fluctuation or a buildup of pressure against the diaphragm move the diaphragm but not enough to throw the switch. So when the pressure meets or exceeds a preset level designed into the structure of the switch, does the diaphragm move far enough for mechanical device on the opposite side to close the switch contact and complete the circuit? Yan. So, pag tumaas yung pressure, depende kung ano yung design na pressure need, okay, mapupush niya ito para mag-activate yung switch. So, each switch is rated to close at a certain pressure and must only be installed in a proper location. So, yun yung ginagawa ni pressure switches. So, ulitin na natin, si pressure gauge for various components or system work similarly to those na nasabi natin kanina. So, some sort of the sensing device appropriate for the pressure being measured or monitored is matched with an indicating display system. So, I hope meron kayo naintindihan ito and pwede nyo namang basahin ulit.